Dear students, let's discuss how to write molecular formula or chemical formula of a ionic compound. Molecular formula and chemical formula are the two names for the same thing. That molecular formula also represent one molecule of a compound and chemical formula as well represent one molecule of the compound. Which compounds formula we can make on our own or we can frame on our own? Those which are made of ions or radicals. What do we need to write the molecular formula? We need just symbol of the radical and second valency of the radical. How to do it? Go about. They are very simple steps and the name of the method is crisscross method. When we'll go about, you yourself will understand why have we named it as crisscross method. So first step toward framing the formula of a compound is writing the symbols of the radical. Which radicals? A compound, a ionic compound, a compound framed of ions is said to be ionic compound. Like water is not a ionic compound because it is not framed of hydrogen ion and oxide ion. It is framed of hydrogen and oxygen atoms. But sodium chloride is an ionic compound because sodium chloride is framed of sodium ion and chloride ion. So how to go about it? First we have to write the symbol of the radicals. Radicals are of two types, cation and anion. Cation one on the left hand side, anion one on the right hand side. Same is about their name as well. See, in the compound's name calcium oxide, calcium ion or cation is written on the left side and anion is written on the right hand side. So same we do while writing their symbols. Like for calcium oxide, if we have to write the symbols, first we will write of calcium ion, that is the cation, and second we will write of oxide, that is the anion. And the full symbol with charge won't be written. We won't write Ca+2, rather we write its valency above it because the second step is to write valency of the symbol. So though symbol is Ca2 plus and oxides O2 minus, but we don't write full symbol. We write only base of the symbol. When we write the symbol, we write base of the symbol without the charge. So while framing formula for calcium oxide, we will write calcium ion symbol but only base, and +2 is the charge, so valency will be 2. Similarly, oxide ions -2 is the charge, so valency will be 2. It means it is very easy to understand if you have learned the symbol. Amount of charge is equivalent to valency. If charge is -3, valency is 3. If charge is +3, then also valency is 3 because valency is amount of charge, not nature of charge. After writing the valencies of the symbol, what we have to do is we have to interchange them, but before that we bring them to lowest number. It means lowest ratio. How we reduce the ratio? By dividing with a common factor. Look at these two valencies, 2 and 2. It has a common factor 2. It means we can divide it by 2. Both can be divided by 2. And after dividing by 2, the valencies are to be interchanged. Cation's valency will go to anion and anion's valency will go to cation. After dividing by 2, the valency has become 1 and 1. It means calcium and oxides both valency rather than 2 and 2, it has become 1 and 1 in its simplest ratio. And in the simplest ratio, then valency of cation to anion and anion to cation. Because of this interchange only, and see the sign, this method is named as crisscross method because in this we interchange the valencies. And after interchanging the valency, we write the interchange number below the symbol. It means Ca1O1. But actually 1 we need not to mention. So we can skip this step and can directly write, or we can write like this and then we can write CaO, because in the formula one number is not mentioned. Like in the formula of water, we write H2O. We don't write H2O1. Though there are 2 hydrogen atom and 1 oxygen atom, but we don't mention 1 because we don't write, even if we don't write 1, it is understood that in water it is 2 atoms of hydrogen and 1 of oxygen. Similarly, in NaCl, sodium chloride formula, we do not write Na1Cl1 because if we don't write any number, it means the number is 1. So here as well, finally the formula has come, calcium oxide. To understand it even more better, let's take one more example, ammonium sulfate. So as the name as well is having cation first, so we write cation first and on left hand side, but we do not write its charge, we write its valency. So valency plus 1 is the charge, so valency is 1. Then the base formula or base symbol of sulfate is to be written, charge is not to be written, SO4. Rather than -2, we write its valency 2. It means when we write the symbol, we write symbol without charge. Symbol of cation, symbol of anion, but we don't write their charge, we write their valencies with a little gap above them. We could have written them below them as well, then also it doesn't make any difference, because finally what we have to do is that we have to do crisscross, that is valency of cation will go to anion and valency of anion will come to cation, that is interchange of valencies. So, and 1 and 2 are already the simplest ratio, we cannot make it simpler. So we simply interchange the valency. After interchanging the valency, ammonium ion is made up of 5 atoms, and 5 atoms together is working as a single unit. So valency belongs to the whole unit. That's why we put a bracket and then we write the number 2. For sulfate as well is a polyatomic radical, means a radical consisting of many atoms, but we need not to write 1, so we can simply leave it. Otherwise, if we wish, we can write SO4 as well, but in the next step we will cancel the 1 number and so the bracket. Finally the formula will become NH4 whole twice SO4 for ammonium sulfate. Let's come to aluminium hydroxide, one more example just to understand it better, and the steps are every time same. First is write the symbol of cation, then write symbol of anion. Do not write their charge but write their valencies above them. 3 valency of aluminium because its charge is +3, so valency is 3. Its charge is -1, so valency is 1. It means charge may be minus or plus, but valency is a number only. Then 3 and 1 are again in simplest ratio, so we can interchange the valencies, and finally the formula will come Al1 we need not to write, and OH3, but OH is again a radical with 2 atoms, means more than 1 atom, so bracket is to be framed, and then 3. How do we read it? AlOH whole thrice, just the way we read it. NH4 whole twice SO4. Why do we read it whole twice, whole thrice? Because this number belongs to all the atoms written in the bracket, because together those atoms form only one radical. One more example, calcium bicarbonate. Calcium base formula Ca, bicarbonate base formula HCO3. Valency of calcium is 2, valency of bicarbonate is 1. Then we interchange the valency, and finally Ca1 we need not to write. HCO3 is polyatomic radical, so we put a bracket and write 2. So the formula has become CaHCO3 whole twice. We can do one more formula for the practice. Suppose we take aluminium, no, we take something else, like we take ferric chloride. Ferric chloride, ferric, iron, 3 valency, chloride, 1 valency. We interchange the valency and finally the formula becomes Fe1Cl3 or FeCl3. This is how you have to do framing of formula. The only thing important is that you should have learnt formula means symbol of the radicals correctly, so that you can write the correct symbol and correct valency. All the best.